Menstrual cycle is defined as a periodic, regular, rhythmic changes that occur in female reproductive organs characterized by periodic vaginal bleeding associated with endometrial shedding. The average duration of cycle is 28 days, but the normal range is quite wide, that it may range between 20 to 45 days. The days are numbered in terms of menstrual bleeding, day 1 of the cycle being the first day of menstrual bleeding. Ovulation takes place at about 14th day of the cycle. If the cycle length is shorter or longer than 28 days, the variation is generally in the period before ovulation. That is, interval between ovulation and the end of the cycle is essentially constant at 14 days irrespective of the cycle length. The reproductive cycle consists of 4 cycles, that is ovarian cycle, uterine cycle, cervical cycle and vaginal cycle. Coming to ovarian cycle. Ovarian cycle depends on the gonadotropin secretion which begins at puberty, that is at around 18 to 13 years. During 8th year, the large quantity of gonadotropin releasing hormone is secreted which initiates a monthly sexual cycle. Gonadotropin releasing hormone shows increase or decrease in secretion which is responsible for cyclical changes in the ovary. There are 3 phases in ovarian cycle. The first phase is follicular phase or estrogenic phase, second phase is phase of ovulation, and third phase is luteal or progestational phase. Follicular phase. During fetal development, ovaries contain several million primordial follicles. However, many undergo atresia, that is involution, before birth, and others are lost after birth. At the time of birth, there are 2 million ova. 50% of these are atretic. The normal ova undergo the first part of the first meiotic division and enter a stage of arrest in prophase which persists until adulthood. Atresia continues during development and the number of ova in both the ovaries at puberty is less than 3 lakhs. Only one of those ova per cycle, that is 500 in normal reproductive life, normally reaches maturity. The remaining degenerates. Just before ovulation, first meiotic division is completed. One of the daughter cells, the secondary oocyte, immediately begins the second meiotic division, but this division stops at metaphase and is completed only when sperm penetrates oocyte. At the start of each cycle, several of these follicles enlarges. One of the follicle in one ovary starts to grow at 6th day and become dominant follicle, and others regresses forming atretic follicle. Follicle secretes estrogen for the final maturation. The cells of the theca interna of follicle are the primary source of circulating estrogen. So this is the diagram of ovary showing the different phases of ovarian cycle, that is primary follicle, secondary follicle, then it is showing the graph in follicle, and then it is showing a stage of ovulation. Ovulation. The rupture of graphene follicle releases secondary oocyte occurs on the 14th day by LH hormone. This process is called as ovulation. The secondary oocyte moves towards surface of ovary and protrudes through the outer layer. The protruding outer wall of the follicle swells rapidly, and a small area in the center of the follicular capsule called stigma protrudes like a nipple. In another 30 minutes, the fluid begins to ooze from the follicle through stigma, and about 2 minutes later, the stigma ruptures widely, allowing more viscous fluid which has occupied the central portion of the follicle to evaginate outward. This viscous fluid contains ovum surrounded by mass of several thousands of small granulosa cells called corona radiata. The follicle that ruptures at the time of ovulation is promptly filled with blood and is called as corpus hemorrhagicum. The granulosa and theca cells of the follicle lining promptly begins to proliferate, and clotted blood is rapidly replaced by yellowish, lipid-rich luteal cells forming corpus luteum. This initiates the luteal phase of menstrual cycle. Mechanism of ovulation. The follicle secretes estrogen, which stimulates hypothalamus and pituitary to release LH. That is, it, it is 6 to 10 times, and it is called as LH surge, and FSH by two folds. LH and FSH are required for the final maturation of the follicle. Estrogen in high dose results in positive feedback effect, which whereas in moderate dose, negative feedback effect is produced. Then in luteal phase, granulosa and theca cells of follicle begin to proliferate and clotted blood is replaced by yellowish lipid-rich luteal cells forming corpus luteum. Luteal cells secrete estrogen and progesterone. If the fertilization persists, LH maintains the pregnancy, and no pregnancy, corpus luteum degenerates to form corpus albicans. So this is a diagram showing different phases of menstrual cycle, phase of bleeding, stage of proliferation, stage of secretory, and in the ovarian cycle, there are the stages of uh, follicular and the luteal phase. For the follicle phase, the estradiol hormone is responsible, and in the middle, it causes the FSH and LH surge, especially the LH surge, which leads to ovulation. And thus, the ovulation occurs, and the ovum, therefore, it is going to start produce progesterone, and that forms the, the luteal phase. Uterine cycle, the changes occurring in the endometrium to prepare it to receive the fertilized ovum, then for implantation constitutes uterine cycle. The phases of uterine cycle. There is a proliferative stage, that is the first, that is 5th to 14th day, and which is mainly maintained or influenced by the hormone estrogen. And second phase is secretory phase, that is between 15 to 28 days, where it is influenced by mainly progesterone as well as estrogen. And the third phase, menstrual phase, that is the first 4 days, and it can prolong up to 8 days. Proliferative stage or estrogenic phase. It is the period between the menstruation and the ovulation, and it represents the restoration of the epithelium from the preceding menstruation. It corresponds to the follicular phase of ovarian cycle. The estrogen secreted from the developing ovarian follicles under the influence of FSH is responsible for this phase. The changes that occur during proliferating phase are there will be proliferation of endometrial tissue from 2 mm to 4.5 mm in 5th to 14th days of the menstrual cycle. As the thickness increases, the uterine gland is drawn out so that they lengthen. Then there will be proliferation of the glands and blood vessels. There will be restoration of the epithelium of the endometrium within 7 days. The secretory or progestational phase, it is the period between the ovulation and the next menstruation. It corresponds to luteal phase of the ovarian cycle, and so the hormone responsible is progesterone and estrogen. Here, the endometrial thickness increases from 6 to 8 millimeters. The endometrial gland becomes tortuous and begins to secrete. The proliferation of the cytoplasm, deposition of the lipids, glycogen is seen. There is increased vascularity of the endometrium, which is proportional to the activity of the gland. The spiral arteries become more tortuous. Arteriovenous anastomosis and anastomosis between veins occur in this phase. The third phase is menstrual cycle, as corpus luteum regresses so that the hormone support is withdrawn and thus endometrium becomes thin. The spiral arteries become more tortuous and they undergo vasospasm by prostaglandin F2 alpha. This leads to ischemia and necrosis of tissue and the walls rupture. Sequential shedding occurs layer by layer in 3 to 5 days. Menstrual blood is predominantly arterial with only 25% of the blood being of venous origin. Menstrual blood consists of shed endometrium, secretion of glands, and blood from spiral artery. The amount of blood lost may range normally from slight spotting to 80 ml. Average amount of the blood loss is around 30 ml. The clotting of blood resolved by fibrinolysin system. Cervical cycle. Though cervix is continuous with the uterus, it shows a separate cycle. Here, no shedding of mucosa occurs, but mucus shows changes due to the actions of hormones. Changes that are seen in cervical cycle. During proliferative phase, cervical secretion is thin, alkaline due to estrogen, and this is to enable sperm survival and transportation. During ovulatory phase, cervical secretion is thinnest, increases the elasticity or spinner barket, therefore can be stretched to 8 to 12 centimeters. Moreover, it dries in an arborizing fern-like pattern when a thin layer is spread on the slide. In secretory phase, cervical secretion is thick, tenacious, and cellular. So this is the fern pattern which is seen during till the 14th day, and this is the mid luteal phase where the mucus becomes thick and cellular because of the effect of estrogen. Vaginal cycle. During proliferative phase under influence of estrogen, vaginal epithelium becomes cornified and can be identified as a vaginal smear. During secretory phase under influence of progesterone, a thick mucus is secreted and the epithelium proliferates and become infiltrated with leukocytes. So this are the diagram showing cervical stage and vaginal stage. The cervical stage, the cervical mucus is thin, alkaline, and shows fern pattern. During progesterone phase, it becomes mucus and tenacious, whereas the vaginal epithelium under the influence of estrogen in follicular phase is cornified and there is a thick epithelium, and under the influence of progesterone in luteal phase it is proliferative and mucus is infiltrated by leukocytes. Hormonal control of menstrual cycle. The regulation is based on the hypothalamo-pituitary gonadal axis and feedback actions of estrogen and progesterone. The gonadotropin releasing hormone is secreted in episodic burst to stimulate secretion of LH and FSH from the anterior pituitary, which acts on the ovary. At the start of the cycle, there is very low levels of estrogen and progesterone, therefore minimum feedback inhibition. So GnRH secretion increases and there is increased FSH and LH. Follicle stimulating hormones now causes development of the follicle and LH receptors. LH does not act on the follicle. The LH acts on the theca cells which produces androgens. These androgens are subsequently converted into estrogen in granulosa cells. Estrogen at this stage causes feedback inhibition of LH, FSH and gonadotropin releasing hormone, but more on FSH, which is further helped by inhibin acting at the level of pituitary. Towards the middle of the cycle, due to the further development of the follicle, estrogen secretion increases further. This persistent high levels of estrogen increases the responsiveness of the pituitary gonadotropin to gonadotropin releasing hormone. There is also increased secretion of GnRH. All these results in positive feedback action where there is a rapid rise of LH secretion, which is called as LH surge, which is thought to be the cause of ovulation. The estrogen level increases 25 hours before the LH surge, occurs about 9 hours before ovulation, that is after estrogen peak. At this time, there is also FSH peak due to both estrogen and progesterone. After ovulation, corpus luteum is formed which secretes both estrogen and progesterone. So there is a feedback inhibition of both LH and FSH. At this stage, positive feedback action by estrogen cannot occur due to the inhibitory effects of high levels of progesterone. Towards the end of the cycle, estrogen progesterone levels become very much low again. This removes the feedback inhibition, so there is a rise of GnRH pulses as well as increased output of FSH and LH to start the cycle again. So this diagram showing the feedback interaction involved to control the ovarian activity at the start of the cycle. So there'll be increased levels of GnRH, FSH, LH is going to lead to the stimulation of the ovarian cycle, and so there'll be gradually increase in the secretion of estrogen, and also because of the sustained levels of high estrogen levels, so that is going to lead to LH and FSH surge, mainly the LH surge, which is going to lead to the ovulation. And after ovulation, corpus luteum starts producing estrogen and progesterone, and at the end, so there'll be again fall in the estrogen and progesterone levels. It is going to increase the levels of GnRH and LH, FSH, which is going to restart the ovarian cycle again, or reproductive cycle again. So these are the hormonal changes that you can see. The estrogen, progesterone, especially estrogen, the peak occurs at the ovulation, and the progesterone peak occurs in the luteal phase. Whereas LH surge occurs during ovulation. I mean, that is the reason for the ovulation with the FSH surge.